Hey guys, welcome to question MM348 of the Maths Methods Fortify study guide. So, in this question we've got the rangers at a parkland in Melbourne have decided to plant small trees in a section of park to improve its aesthetic. A bird's eye view of the parkland is shown below. A river runs along the y-axis, so along here, and walking tracks in this section are modelled by the x-axis and the graphs of y equals f of x and g of x, where f of x and g of x are equal to these two things here. There are bridges at O and A, so here and here, allowing walkers to cross the river. The shaded region is the section where the trees will be planted. All measurements are given in meters. Awesome. So part A, which is a 1-mark question, says how far up the river is the bridge at A from the bridge at O. Awesome. Our bridge at O is at the origin, and our bridge at A is at the y-intercept of f of x. Okay, so f of x at y-int is A. So where do we find our y-intercept? Where x equals 0. So f of 0 is equal to 10, 0 plus 50, which is 10 root 50. And we can actually simplify this to 10, 25 times 2. Square root of 25 is 5, so 50 root 2 meters from from O. Awesome. And that's our first and final mark for part A. Let's move on to part B. Part B is a 2-mark question. And it says, find the coordinates of P, the point where f of x take g of x equals 0. Correct 2 decimal places. So this point here. So essentially what we're finding is the point of intersection between these two graphs. So if f of x minus g of x equals 0, then that means that f of x is equal to g of x, right? So if these two are equal, then we can say that 10 root x plus 50, which is our f of x, equals our g of x. X take 100 squared over 100. Awesome. So what we really want to do here is solve for x. So what we're going to do is solve in CAS, and that gives us answers of x equals 11.459 and x equals 229.273. Awesome. So we need to choose which one of these is our correct answer, right? Because we've only got one p-value here. If our if our g of x has to be greater than 100, then that means that our value is x equals 229.273. So we know that our x is equal to 229.27 because we're looking for correct 2 decimal places. That's our first mark. And we get our second mark from our y value because we need to actually find the coordinates of point P. So we can sub this into either f of x or g of x to get our y value. I'm going to sub it into f of x just because I want to. So f of 229.27 is equal to 10 times 229.27 plus 50. And what we get is 167.11, which means that therefore our P occurs at 229.27, 167.11. And that is our second and final mark for part B. Let's move on to part C. Part C is also a 2-mark question and tells us to find the area of the shaded region. So hence, find the area of the shaded region where the trees will be planted. Give your answer to the nearest square meter. Awesome. So 2 marks. So we know that this P occurs at 229.27, 167.11. Awesome. And we're going to need to find this area in between here. So what we're actually going to need to do is split this up into 2 sections, okay? Because at this point here, from negative 50 to 100, we're actually just finding the area under f of x between the x-axis. But then from 100 to 229.27, we're finding the area between f of x and g of x. All right, so we're going to have to split up our area in that way. So the way that we do this is our area is from negative 50 to 100 under f of x dx, right? So that gets from negative 50 to 100 of under f of x, which is this first area here. This is our A1, this is our A2. Plus our A2, which is our area from 100 to 229.27 of f of x minus g of x. Awesome. dx. Cool. Now from here we can actually just sub in our f of x and g of x. So f of x is 10 root x plus 50 dx plus 100 to 229.27 of 10 root x plus 50 minus, do I have enough room? Yep. X, take 100 squared over 100 dx. Fantastic. So what we actually get here is integral of 20, so we can use our CAS for this, and I would, just to make this easier on ourselves. 3 on 2 over 3 from negative 50 to 100, and then plus integral of 20 x plus 50, 3 on 2 on 3 minus x take 100 power of 3 over 300 from 229.27 and 100. Awesome. So this is our first mark right here. Getting that. Actually, probably somewhere in between there would be our first mark as well. Awesome. So then from here, we can just evaluate this in our CAS, and we get 12,247.449 plus 11665.131. And what that ends up being is 23,912.58 meters squared, which is our second and final mark. So that's it for part C. All of this working is necessary, but you can actually do the calculation itself in the calculator. So that's it for part C. Let's move on to part D. Part D is simply a 1-mark question, and it says the rangers plant the trees in the shaded area at a density of K trees per square meter. If a total of 1,000 trees are planted, find the value of K correct to 2 decimal places. Awesome. So as we should kind of be able to work out, the number of trees is equal to the area times the density. Okay, so if we had 1 square meter and the density that we had was 10 trees per square meter, we would have 1 square meter and timesing that by 10, and we'd have 10 total trees, right? So our area, as we figured out, is 23,913, and our number of trees is 1,000, as we've found, and we're timesing this by our density, right, which is K. So K is then equal to 1,000 over 23,913, which equals 0.04 trees per meter squared. That's our first and only mark for this question, and that's it for part D. Let's move on to part E. Part E introduces a new concept, or a new part to the question, and says a particular tree's increase in height over time, h centimeters per year, t years after being planted, is modeled by the equation dh dt equals 20 over t plus a, where t is greater than or equal to 0. 3 years after being planted, this tree is growing at 5 centimeters per year, so that a equals 1. Awesome. So we know that it's growing at 5 centimeters per year. This is our growth rate, or our rate of change, so that's going to be equal to 5 centimeters per year. We also know that this occurs 3 years after being planted, right? So 20 over so 3 plus a. And then from there we can multiply both sides by 3 plus a to get 5. 3 plus a equals 20. Expanding this, we get 15 plus 5a equals 20. Subtracting 15 from both sides, we get 5a equals 5. So therefore a is equal to 1 as required. Awesome. And that's it. So that's our first and only mark for part E. Let's move on to part F. Part F is a 2-mark question, and I probably shouldn't have rubbed that out. That's all right. Awesome. Cool. So find a rule. So F says find a rule for the function h of t, the height of this tree t years after being planted. This tree was planted when it was 1 meter tall. All right. Awesome. So in order to find a rule for the function h of t, we're going to need to integrate our derivative, right? Our dh dt. So we have the integral of our dh dt, dt, and that's going to give us our h function. Okay. So we need to integrate our 20 over t plus 1. And we know it's t plus 1 because we found that a was 1 in the previous question. Now, integrating this, we can take 20 out as a constant. We get 1 over t plus 1 dt. 20 times integral of 1 over t plus 1 is log e of t plus 1. If you're not too sure about this, you can use a calculator, so you can do that to work that out. But we also have our plus c on the end, okay? So h of t is equal to 20 log e of t plus 1 plus c, and that's our first mark. So finding that gives us that one. And then we know that the tree was planted when it was 1 meter tall, right? So h of 0 equals 100, all right? So remember, all of these measurements are given in centimeters, not meters. So the height of the tree is 100 when it was first planted, okay? So we just got to be mindful of that. Now our goal is to find out what c is. So we know that h of 0 is 100, which means that 100 equals 20 log e of 0 plus 1 plus c. Now log e of 1 is just 0, so 100 equals c. So therefore h of t is equal to 20 log e of t plus 1 plus 100. And that's our second and final mark for part F. Let's move on to part G. Part G is quite straightforward. It'll just be a simple substitution question. It's 1 mark. And it says, how tall is the tree after 10 years? Give your answer correct to the nearest centimeter. Cool. So we know that our t is going to be 10, because we're looking for 10 years afterwards. So 20 log e of 10 plus 1 plus 100. This gives us an answer of 147.96. Keeping in mind this is a 1 mark question, so you can just write the answer straight out without doing any working. And we are asked to give our answer correct to the nearest centimeter, which means equal to 148 centimeters. That's our first and final mark for part G, and that actually wraps up MM348, guys. So again, as always, let me know if you have any questions in the comments below. But again, thanks for watching, and I will see you in the next video.